Greetings, everybody. Welcome to our WeThink platform and our first session on modern approaches in railway infrastructure asset management. The intention is for this to be the first or the introductory session in a whole series of sessions devoted to the railway asset management systems. And the overall topic of railway asset management, the intention is for us to start with the infrastructure, as it usually consumes most of the budget of all railways. However, the intention is also to expand this later on onto other assets, primarily rolling stock. Let me first tell you a couple of words about myself. My name is Stasha Jovanovic. I'm an associate professor at the Faculty of Technical Sciences, University of Novi in Serbia, Department of Civil Engineering. I'm a civil engineer, and I'm dealing with the railway infrastructure asset management for, well, at least 25 years, starting with my master thesis back in '94 at the University of Belgrade, and during which I started analyzing asset management systems in the railway domain. In fact, the asset management as a term, as we will discuss later on, was not even yet used in the railway domain. At that time, mostly these systems were referred to as maintenance management systems, and in that sense, within my thesis, I analyzed some 17 systems which already existed in the 90s worldwide, even starting in the 1980s. And not all of them were actually really covering the entire domain of asset management as we see it today, but at least they touched upon it, or usually they covered a certain portion of it. Very often they were devoted to only certain assets like rails. Typically in North America, these systems were primarily related to rail replacements, as probably the costliest of all asset groups within the infrastructure. However, there were also some of those systems that had wider scope, and one notable example was actually EcoTrack software, which was a collaborative research of 24 European railways, starting in 91, 92, and ended in sometime in 96, 97. And it was done under the auspices of the UIC and the European Rail Research Institute, called ERI at the time. And this was one of the systems that I also stumbled upon during my master thesis, and actually turned out that a lot of my efforts were actually devoted directly to that system, because it was, at the time, as I saw it, the wide, let's say, with the widest scope and most advanced in terms of most of the currently key aspects of asset management that we see in modern asset management systems. We will talk about this in more detail later. After that, I actually moved to do my Ph.D. at the TU Delft in the Netherlands, and at the same time I split my time. I actually started working for the ERI Institute, and I was exactly working on the EcoTrack software, and actually I was managing it for about 5 years, from '99 to some 2004. And during that, I actually collaborated with a very large number of primarily European railways, but actually it turned out that the EcoTrack software extended with some tests in North America, and also some pilot applications even in Australia, Queensland Rail most notably. After that, actually, after I left ERI, and I moved to Italian company Mermac, which was at that time a primarily condition monitoring oriented company. They were producing various kinds of rail condition monitoring systems, primarily devoted to rail infrastructure, but also some other assets. And what they found out was actually that they were producing a lot of data, but that their customers, railways primarily, were not able to use all that data without a proper system. So they actually had a need for this kind of a system, and I had some useful expertise. So we joined forces, and I actually developed for them a system that was called Ramses. and it's also used nowadays worldwide. So the development took several years, and we actually did several implementations worldwide. After that, in 2013, I moved to ENSCO, which is a North American company, also devoted primarily to the production of condition monitoring systems, and they had the same type of a need, and they wanted to develop a modern asset management system for rail infrastructure and for their clients, their growing, let's say, base of clients, primarily North America, but also worldwide, to be able to actually utilize all of the condition data that ENSCO measuring systems were producing to understand the degradation of assets, to plan maintenance, and to optimize maintenance, and in overall to manage all their infrastructure assets, which actually became the asset management domain. Finally, in addition to the three asset management systems in terms of software solutions in the asset management domain that I dealt with so far, I've been also dealing with the asset management domains in the rail infrastructure, of course, through my consultancy, primarily in Europe, North America, and Australia. And this consultancy primarily was related to the assistance to various railways in terms of optimal application of the asset management practices and the optimal utilization of the eventually existing asset management systems, primarily in the domain of processing of condition monitoring data, understanding the deterioration of assets, using these analyses for maintenance and renewal planning in terms of formulating or optimizing maintenance and renewal decision rules, and finally optimizing the overall maintenance and renewal practice in terms of either introduction of new or improved condition monitoring systems or improved asset management practices. This much about me. We're going to proceed now with our presentation, but before we do that, we would like to extend our gratitude towards our ever-growing population of distinguished supporters. You'll recognize some of the big names in the rail industry, and their support to our endeavors here only proves the importance of the overall rail asset management domain. We're going to start with setting the scene and defining the terminology, because in fact there is a lot of confusion over the past years about the actual term asset management or rail infrastructure asset management. In fact, as I already announced in my introductory part, the term asset management was not coined in the rail industry at all. It was actually not used in the rail industry before early 2000. During the 90s, this term was primarily reserved for the financial domain, like banks were using this term for the asset management of financial assets. And after that, actually, this term spilled over into the engineering domain, not only rail industry, but also other industries. And in rail industry, first, it was termed as fixed assets management. But then it converted into overall either rail infrastructure asset management or rolling stock asset management. So what you can see on the slide is arguably most comprehensive and most accurate representation and interpretation of the asset management, at least that I have managed to stumble upon so far. And in that sense, basically, we can use the ISO 55000 definition of it, which basically defines asset management as the coordinated activity of an organization to realize value from assets. As you can see on the structure here that is presented, basically asset management encompasses a lot of subdomains, and certainly this slide does not cover all of them, as this is a living thing. It's a living organism that is actually changing every day. So new aspects are being added to it. And certainly we are going to be discussing some of those that might not be even existing on this slide here. And we are going to be analyzing throughout this series of sessions many of those items that are presented on this slide. But I would draw your attention to the fact that what you can see at the lower end of this slide, and that is that asset management basically starts from the very phase of planning of the infrastructure asset, be that rail or road in that sense. And of course, we're here talking about rail. But important thing is that it starts all the way in the from the planning phase, and then extends onto the construction, and later on, once the infrastructure is put in operation, maintenance and fault management and rebuilding and so on. Also, it encompasses, as you can see here, all the innovations, the standards that are being applied. And when mentioning standards, we also need to understand that those standards are also a living organism that should be updated regularly. For the railroads, say for the first several decades of the railroad's existence, standards were not being changed very quickly because the technology was not changing very quickly. Nowadays, however, over the last several decades, technology is changing so rapidly that all the standards, and we will be discussing this issue extensively in terms of thresholds definition for various condition monitoring parameters concerning the condition and behavior of various rail infrastructure assets. All those things should be constantly questioned, and standards should be changed, and all these results should be constantly embedded and modified within the asset management domain and the asset management system. So as we can see in the core of the asset management as represented on this slide, we can see investments, which are extremely important because at the end of the day, whatever we are managing, I mean, this infrastructure that we are managing is actually exposed to a certain budget, and we need to, and this is a constraint for us within which we have to operate. We then, of course, need to respect the aspects coming from the actual organization that is in charge of the infrastructure. In this case, we're talking about railroads, or in the modern terms, at least European terms, we're talking about the infrastructure managers. And then, of course, within the maintenance and renewal management, we need to understand all the maintenance strategies. And this is something we're going to be discussing very extensively throughout all these sessions and the entire series of sessions, actually. Of course, the asset assessment and risk management is extremely important aspect of it, which comes hand in hand with maintenance strategies. And of course, there we also have innovation management and life cycle analyses, which is again something we are going to be discussing extensively, and which is because it is actually a very important constitutive part of asset management. At the end, of course, as a result of all these subtopics, subdomains, and the entire asset management process, on the right-hand side, you can see that the result is actually the optimization of track or the entire network, in fact, of all the infrastructure that we are dealing with and that we are actually managing within this entire asset management process. In the sense of what was said at the previous slide, we can conclude that there isn't really an established definition of the rail infrastructure asset management concept or asset management systems for that matter, but the terms asset management, and asset management system are defined in ISO 55000, which provides a proper foundation, at least, for the generic interpretation of the asset management system in the field of railway infrastructure. In fact, the RIAMs or RIAMs, and well, this term is still being coined, so I'm welcoming all of you to come up with any ideas as to how it should be pronounced. In reality, though, for most existing railways with existing infrastructure networks, asset management primarily equates and converts into the maintenance and renewal management, which is what I already mentioned at the beginning of this session when we were talking about the origins of the asset management term within the rail industry starting sometime late 90s, early 2000s. And in that sense, management of maintenance and renewal interventions is actually defined as the decision-making process that determines what to do and when and where to execute maintenance and renewal activities so as to keep the railway infrastructure in a desired condition, considering the necessary resources and budget. This is like the condensed, digested version of the asset management definition within the domain of maintenance and renewal management. Now that we have defined maintenance and renewal as the core issue of the asset management, we need to clarify and understand the importance of it. So why is it that we bother at all with this issue in the first place? And in that sense, I will actually borrow the very informative figure coming from the 1994 book Modern Pavement Management by Hudson House and Zaniewski, and obviously which comes from the road domain, but is equally applicable to the rail domain. And I will just remind you that in terms of rail infrastructure, basically now we are approaching the 200-year anniversary of the start of modern railways, taking as the starting point the construction of the Stockton-Darlington railroad line in England in 1825. So we're very close indeed to the 200 year anniversary of it. And within those 200 years, we can actually see when we look back that the railroad infrastructure has endured, in many cases, well, more than 100 years, because lots of railroads that we see nowadays and that constitute the current worldwide rail network are actually built in the 19th century. And of course, they've encountered numerous, let's say, modifications and renewals since then, but still, basically, and it is still very often sitting on the old route that was being built in 19th century, which means that the substructure and many civil works like the bridges, tunnels, and stuff are still originating from the 19th centuries, which all points out to the extreme durability of the infrastructure assets. And we know the same thing to be true for roads, but in this case, in terms of modern railroads and roads, railroads are actually older than roads. I mean, obviously, roads, if we take ancient roads, are certainly older, much older. But when we talk about modern roads with the flexible or rigid pavements, they are actually younger than the railroads. They originated from the end of the 19th century or early 20th century, whereas, as we just mentioned, the railroads are actually originating from the first half of the 19th century. So, having this in mind and understanding that basically every infrastructure network or asset goes through a series of phases, starting with planning, design, followed by construction and maintenance during the operation of that infrastructure asset, and which actually echoes what we already mentioned at one of the previous slides, when we were talking about the overall definition of the concept of asset management. We need to see that we can recognize two things that are really pronounced in the within the asset management domain, and there are the costs, and we can see now the red dashed line showing the rise of costs throughout the lifetime of an asset of a let's say railway line, and the other thing is the level of influence that we have on those costs actually throughout again the entire service life of this asset, which is, as we mentioned, very, very long. I mean, we're talking at least 100 years when we are talking about the railroad line. So within that very long period of time, the maintenance costs, actually, as we see it now, they are actually showing that more than half of those costs are actually accumulated throughout the operation of that infrastructure asset, which means they're actually collected by the maintenance renewal costs that are being collected over the times that this asset is being exploited.
and the all the previous costs, the from the phases of planning, design, and construction, are actually constituted the minority of the overall costs. Nevertheless, most of the countries, I would say, primarily countries, less so perhaps private railroads, when deciding about building and constructing and operating a railroad line, they're primarily focusing on the first three phases: planning, design, and construction, for the very, I would say, selfish reason, and that is that it lasts short enough for them, for meaning for the decision makers, or those or those that are involved in this construction in whichever way, to be there throughout those phases. Whereas the maintenance and the operation phase, taking more than 50 or more than 100 years, is certainly falling way beyond their let's say career life, and they will not have any impact or influence on them, or any benefit from them, for that matter, and which may be even more important. This is why that most of the people also at railways, but primarily at ministries and so on, when thinking about railroad lines, they're primarily thinking about design and construction, and within between the two, construction even more than design, as it costs much more than design, and still happens within, let's say, 5 to 10 years time span, which is short enough for them to kind of have influence on it. So, and the same thing goes for the banks. The banks are also primarily interested in financing design and construction of railroad lines, and they're less so interested in financing anything which has to do with the maintenance and renewal of those lines. It's also because of the fact that the banks are also thinking pretty much short term, and primarily that short term is related to the actual positions that certain people within banks are holding while these activities are taking place. So for them, again, something that takes place in within 5, 10 years time does make sense, because it falls within the domain, the time domain, that they will retain certain positions within the banks and could somehow benefit from bonuses or whatever that they might be receiving from the successful application of those activities. Whereas maintenance renewal taking place within the time frame of 50 to 100 years is far long for them to see any benefit coming eventually from them. So this is why the focus is primarily placed on the first three phases, and I would say undeservedly so, because actually, as you see it on this picture, it is the maintenance renewal phase, the operation phase of the or the exploitation phase of the rail infrastructure, that should deserve much more attention. In the sense of the level of influence that we have on those costs, we should say that we have to start with the planning phase, actually the start of the planning phase, and this is where we have, trivially speaking, we have 100% influence. We have the 100% influence in the sense that we could actually decide not to build a certain railroad line, and in that sense, we will have saved all these costs to be used for something else that might be of interest for that particular country, for example. So of course this is trivial, but it does represent a 100% influence, because we can decide not to build this line, and we will have saved the entire budget, both for construction and for maintenance. As soon as we take a decision about whatever decision within the planning phase, no matter how small and the cost of that decision may be, and the duration of that decision making process, still already the level of influence drops. It doesn't drop significantly. It drops for maybe 1 to 3%, but still it drops. And of course, what is important here is that every good decision that we made during the planning phase, and any other phase that comes after that, as well as every bad decision, and unfortunately, we are primarily feeling those bad decisions. We're kind of taking it for granted all the good decisions. So every good or bad decision will have direct influence onto the all the subsequent costs. So every bad decision that we make, every shortcut that we take in the either planning or design or construction phase, for example, we use some weaker elements to build this line, or maybe inferior methods, construction methods, and so on. So all the mistakes that we make in construction will actually, or might certainly have dire effects on the on what's happening throughout the exploitation phase, and primarily onto the maintenance and renewal costs. So through the design phase, very similar as with the planning phase, we still can take various decisions, and once we take them, our level of influence, potential level of influence on the reduction or increase of those costs drops. And then we go into the construction phase, and we already mentioned that the decisions that we make there and everything that we do throughout the construction phase, which alone does actually constitute a significant part of the overall cost, but still small in comparison to the exploitation phase and maintenance renewal costs that accumulate through it. So all the decisions that we take there are again going to influence the overall costs. And as soon as the construction phase is over, the exploitation phase starts, and maintenance and renewal activities start from that day on. And finally, what is most important from the asset management point of view, and that is that within this exploitation phase, there is still a lot of influence, potential for the influence to be exerted onto the remaining costs, and so that we can, as a result, save a lot of objective costs at the end. And this is primarily because the exploitation phase, where maintenance renewal costs are happening, is actually accounted for the largest portion of the overall life cycle costs. The previous slide, we mentioned many times the costs, maintenance renewal costs. So let's see now what are really those maintenance renewal costs and why is that important for us. Here we can see the total maintenance renewal cost on the Dutch railway network coming from the Modern Railway Track book of Conrad Esveld from 2001, which shows that basically for a network size of 4,500 kilometers, the average expenditures, and for the track only here, that is very important to stress, track only was about 250 million per year, which means it's about 50,000 euro per kilometer per year. And this is the level of costs that is present at most of the advanced European railroads since, let's say, roughly the year 2000, and it could have gone only up. Within those costs, we can see that the share is basically 70% goes to the renewals, about 20% goes to manual maintenance, about 10% goes to the mechanical maintenance. And obviously, these are huge costs, and that is what constitutes one of the main motivations for the application of the asset management, and that is to try to reduce or at least control those costs from escalating. And they can escalate if the quality of infrastructure assets is not permanently monitored and kept at check. So when we take into account the fact that the track that we just mentioned before, accounting for about 50,000 euros per kilometer every year, constitutes about 40% of all the infrastructure costs, then calculating the total cost for all the infrastructure amounts to roughly 125,000 euro per kilometer every year, and that is valid for the conventional lines. As for the high-speed lines or heavy haul lines, these costs can be even higher and considerably higher. This brings us to the key prerequisites and key challenges set forth any successful application of either asset management concept or asset management systems. In terms of key prerequisites, important is the validated models to calculate the achievable network quality for a given budget and vice versa. It is absolutely indispensable to have them. Then we get the degradation models, and we're going to be discussing extensively degradation models throughout many of the sessions in this series of sessions. So the degradation models for most important assets. Then we need to understand and constantly monitor the effects of maintenance onto the quality of all the assets. Assessment of corrective, preventive, and condition-based maintenance strategies. We need to be assessing the effectiveness of the maintenance strategies that we are deploying, and we need to be modifying them constantly uh, from the using the experiences that we got from the previous applications. So we need to be updating them constantly. Then the availability of qualified historical data for the key assets with respect to RAMs and LCC, and we're going to be discussing the later too in the subsequent slides. So this availability of the historical data has to be secured at all times. Without the data, any asset management concept or asset management system is completely useless. And finally, comprehensible and verifiable decisions. So all the decisions that we take must be really verifiable. We need to really challenge them and question them at all times, and then improve them using the experiences from the previous decisions. We cannot stick to the same decisions that we applied in the past. This is exactly one of the important um, things of concerning the evolution of the asset management system at any railway. In terms of the key challenges, one of the most important challenges is actually traditional lack of cooperation between the four different railway system sectors defined by the UIC. This, which is basically originating from the old days of railroads, even coming all the way from the 19th and 20th century, and that was a very strict, uh, let's say, division of jurisdictions uh, and responsibilities between the four sectors, being track and structures, train control interaction, control command signaling and operations, and energy management and rolling stock. Those sections were typically entrenched in their positions over the past decades or even centuries, and they did not learn to communicate with each other. So for the successful application of asset management, these four sectors must be brought together, must be made to communicate between themselves, and because only in their interaction could the asset management system truly become functional. So at the previous slide, we mentioned deterioration modeling, and we're going to be talking about this issue extensively. But here, when talking about the railway infrastructure, we need to understand that actually we can divide the behavior of different infrastructure assets into four groups. First group is observable gradual failure progression. Then we get the second group is non-observable failure progression. Then we have observable but sudden failure progression. And we have shock progression, which is actually extremely quick and sudden failure progression. So luckily for us, most of the infrastructure assets, and primarily we're talking about track assets, which anyways consume most of the infrastructure maintenance and renewal budget, fall in the domain of condition-based maintenance. Basically, they fall in the domain of observable gradual failure progression, on which we can apply condition-based approach coupled by the life cycle costing approach. As for the other three groups, which are happening either too fast, or they may be happening like the group number two, they may be happening not so fast, but actually their manifestation is non-observable. For those assets, we are actually applying other type of methods, and they're based on probability and risk-based methods like RAMs, reliability, availability, maintainability, and safety, RBM, RCM, and so on. Having mentioned RAMs and LCC, we need to define their position within the asset management domain and their actual functions within it. In that sense, in terms of RAMs, basically it falls within the domain of technical specifications, and it's related to the definition of specifications regarding operation and maintenance quality in the sense of describing the quality specifications through RAMs values. In terms of life cycle costing, it falls within the domain of economical specifications, and there we have first the cost benefit analyses, the result of which is the definition of the specifications regarding total life cycle costs of all the infrastructure assets, and that has its implications through all the phases of the life cycle of rail infrastructure assets, starting from procurement, operations, maintenance, and non-availability. So overall, what are the rail infrastructure asset management postulates? What are the most important aspects to bear in mind all the time throughout the application of asset management concept? And that is always build according to norms, but also reevaluate the norms regularly. So, which means don't rest on the laurels of previous norms. Always update those norms regularly with respect to the latest technology that is become available. Measure and monitor condition from every possible aspect. This cannot be understressed. This is probably the single most crucial aspect of asset management, and that is the ability to measure and monitor condition of every single asset and from every single possible aspect of it. Costs of condition monitoring are insignificant with respect to the costs of maintenance renewal, let alone the costs of the incidents that can happen due to inadequate condition of infrastructure assets. Then, extremely important thing is to always plan objectively and perform adequate and timely maintenance renewal activities, which come only as a consequence of proper condition monitoring and proper condition analysis and condition analysis based maintenance and renewal planning, which is again, in fact, in turn based on deterioration modeling, because in fact, condition monitoring analysis is effectively deterioration modeling. Then everything needs to be documented regularly and in detail, especially measurements and activities, because without registering measurements and activities, you cannot really understand the progression of condition of different assets. For the progression of condition, of course, you need measurements, so you need to align all the previous measurements to see the time progression. But equally important are the records of the activities, maintenance and renewal works that are performed on those assets, because those works should have brought the improvement of in condition of those assets. And if you don't know when those activities were performed, it could not be assessed whether they have indeed brought this improvement or not. And if they have not brought improvement, well, the first conclusion, an obvious conclusion is, well, we should stop doing those activities and we should consider doing something else that is more effective. And finally, we should be constantly using all the above to question the maintenance renewal policies and redefine them and update them as necessary, especially as new and advanced technologies become available. So, all in all, having all the previously said in our minds, what should be the ultimate goal of railway infrastructure asset management systems, as in fact the embodiment of the asset management concept? Well, the goals should be to always stay in permanent control over the condition of all infrastructure assets, which means we do not want the condition of assets to surprise us ever. We want to be ahead of their assets behavior. We want to be in control, in constant monitoring and following of their deterioration, because they will certainly not be improving, at least not on their own. But we need to be monitoring their deterioration, and it has to be controlled deterioration so that we can act before certain incidents could ever happen. Then we want to be permanently to have at our disposal and be able to promptly access up-to-date and reliable data for identification of maintenance renewal requirements in order to predict, plan, schedule, carry on, and report and record maintenance and renewal activities. We want to be able to optimize resources and yet deal adequately with the urgencies at the same time. And all that, in fact, directs us to our ultimate goal, and that is to have safe, reliable, and efficient rail traffic and maximally available infrastructure. Now that we have zeroed in on RIAMs, on the Railway Infrastructure Asset Management Systems, the first thing we need to take a look at is the typical sequence of operations covered by the RIAMs. So here you can see the several steps that, mandatory steps that any such system has to cover. And basically those steps consist of data acquisitions, data validation, track segmentation, deterioration modeling, maintenance renewal planning, and resource allocation and overall optimization. We're going to be going through all of those steps in detail. However, in the narrowest of senses, RIAMs basically focus on these four steps, whereas the first step, data acquisition, quite often resides outside the actual asset management system and could be covered by some external systems, starting from those systems installed on the condition monitoring vehicles and so on. And similarly so, the last step, resource allocation and overall optimization, is quite often residing within the ERP systems, enterprise resource planning systems, that are usually accompanying the asset management systems. And they're basically accompanying and complementing their capabilities in the sense of exactly performing the resource allocation and overall optimizations. So, in the narrowest sense, asset management systems are dealing with the technical aspect of asset condition analysis, the deterioration modeling, and maintenance renewal planning, whereas very often ERP systems are actually dealing with the further resource allocation, reshuffling of work orders, and stuff like that. In a bit more detailed overview, we can see here quite a busy slide, but it's not that complicated really if you take a good look at it. The first thing we should take a look at is at the bottom of the slide, and it's the division of jurisdictions between the various software systems. And this is exactly a continuation of what we just mentioned. And that is that, as you can see, the asset management systems, they basically start with data analysis by alert generation, planning, optimizations, and somewhat scheduling. And then the scheduling and execution is typically covered by the ERP systems. They could be covered by the asset management system in some cases, but if there is no ERP system, but if there is an ERP system, usually these two things, scheduling and execution, is covered by the ERP systems. At the end, control, again, is taken over by the asset management systems. Within the asset management systems, the decision support systems are, again, something which falls within these three, four groups of activities, starting from alert generation, planning, optimization. I wouldn't go into scheduling. So basically, these three are usually covered by some of the systems that are typically called decision support systems. As opposed to that, the first step, monitoring or the measurement and video inspection of the systems, is basically the first step that comes prior to the application of asset management systems. And this step covers the measuring of track, rail, ballast, overhead line, and all the rest of the infrastructure assets. It covers detection of critical defects, because these defects are very often, if they're truly critical, they're sent directly straight from the track recording vehicle to the maintenance personnel, responsible maintenance personnel that is supposed to act immediately upon. And so basically there is no time for the asset management system to analyze those defects. If they are truly urgent, they are sent straight from the measuring vehicle. Also, the measurement systems, they also perform sometimes on board, or sometimes in office, validation and localization of the condition monitoring data. That also can be performed within the asset management systems, but often is performed outside them. So this is the first step. Then actually the asset management systems come into the play, and they actually start from the data analysis and alert generation, which means that they take the condition monitoring data coming from the measurement systems, and then they perform either single or cross multiple parameter analyses of various assets and their various condition monitoring parameters. They create various quality indices and KPIs. They create basically the list of defects, and they issue additional set of alerts of warnings, but these are not the urgent ones. Urgent ones are being sent usually straight from the track recording vehicles. The next phase is the planning phase, and this is again something that is performed within the asset management systems, and that phase encompasses degradation, degradation of all the assets in terms of determining also not only the degradation behavior, but also the speed of degradation. It uses the work history and analyzes overall behavior of the assets. Then it does the clustering of the maintenance renewal works for the sake of optimizing them and enhancing their efficiency, and that it basically creates the production of various maintenance and renewal scenarios. After that comes the optimization of those works, and this is already something that may or may not be applied within the ERP systems, but usually it still resides within the asset management systems, and that is something that relates also to the RAMS factors that we mentioned before, and that means checking the line availability and the availability of the resources needed for the maintenance renewal activities, with resources being the track possession periods, which means the track closure periods, which of course directly relate to the track availability, and of course the mechanization, machinery availability, and staff availability. And then of course by optimizing all the resources, the system sets the priorities. Then comes the scheduling, and that means issuing work orders and the final allocation of resources. And as I mentioned, this is already a step that often takes place within the ERP systems. Then comes the execution of maintenance renewal works, in terms of which both the asset management systems or ERP systems are responsible for managing the closure of the work orders within the technical location and economical side of the things in terms of labor hours and the related information. Finally, the asset management systems typically take care of the control of the performed maintenance and renewal works in the sense of calculating the KPIs, which are in fact reflecting the efficiency and efficacy of the performed maintenance renewal works, and all of which, for the sake of reanalyzing them and understanding whether they were uh, performed properly, whether they were effective enough, which means if they were performed justifiably, or if they should be in the next iterations when the similar situation happens either at the same or different location, be replaced by different types of maintenance renewal works, which may be more effective. This brings us to the condition-based approach and its objectives as being the cornerstone of the uh, condition-based asset management systems, and the idea of which is basically to perform a shift from the current situation where the diagnostic data are used primarily for the controlling purposes, to the situation where diagnostic data are used as the driver for maintenance activities. In reality, the situation today is that we are already performing a certain amount of survey activities, condition monitoring activities, but since we are not performing sufficient amount of that, we are actually capable of performing only a certain amount of planned preventive maintenance, and because of that, we are still relying on a huge amount of corrective maintenance. The problem with corrective maintenance is that it happens after a defect has already occurred, which means that you already have the damage, you have the cost of the defect that already happened. Then you might have the cost of some traffic disturbance, because defects usually happen under traffic. So there might be some cost related to the traffic disturbances. And then, since it is happening unplanned and it's happening perhaps under traffic, then we need to rush in order to correct that defect. And when you rush in, it always costs more than when you can plan your activities in advance. So what we actually want to do is we want to increase the surveying activities, the condition monitoring activities, due to which we can actually increase the planned preventive maintenance at the expense of corrective maintenance. Surely, the certain amount of corrective maintenance will always remain, but we want to try to reduce this corrective maintenance as much as possible. By making this shift from this today's situation to this tomorrow situation, the overall maintenance renewal costs, which actually include inside themselves also the surveying activities, the total costs are actually getting reduced. This, in fact, reminds me of something that I came across when returning from one intercontinental flight a long time ago, maybe 10, 15 years ago. I think it says someplace here. Yes, it says 2009 here. So, and this is a slide that basically explains the importance of condition-based approach. Namely, there is always a question: why should we use the condition-based approach in the asset management of rail infrastructure, and why? And in my mind, the answer is quite simple, and that is that as a humanity, we did not actually come up with anything better than that. And the reason and the argument that I use to support this statement is the fact that we are actually using this approach in managing what is most important to us, and that is our health. And actually, I've been mentioning this on occasion at various conferences, and then I ran into this article in this magazine on a plane back to Europe, and I was very happy to read that I was true in stating that the medicine is exactly adopting or is intending to adopt a purely condition-based approach. And what you can see here is that it clearly says that over the next 2 decades, medicine will change from its current reactive mode, in which doctors wait for people to get sick, to a mode that is far more preventive and rational. What's driving this change are powerful new measurement technologies and the so-called systems approach to medicine. The average doctor's office visit might involve blood work and a few measurements such as blood pressure, temperature. In the near future, physicians will collect billions of bytes of information about each individual genes, blood proteins, cells, and historical data. So if this is the best approach, and clearly it is the best approach, because if we had a better one, we would have used it for our health. So if this is the best approach, well, then why not use it for the infrastructure as well? So this explains why condition-based railway infrastructure asset management systems rather than any other approach for the railway infrastructure asset management. And that is that the process of determining whether, when, where, and how to intervene, and deciding on the optimum allocation of resources while minimizing the cost, is extremely complex, because different track sections and assets tend to behave differently under the effects of loading and environment. Decision processes for the maintenance renewal works are closely interrelated and both technically and economically. And finally, the decision making for maintenance renewal plans is based on a huge quantity of technical and economic information, extensive knowledge, and above all, experience. Because of these three arguments, uh, managing this process without a RIAMS, well, the system, the software system, becomes increasingly difficult, if not impossible. So what are the key rail infrastructure asset management systems groups of data that the system must have at its disposal in order to perform all the activities that it's supposed to deliver? So primarily these are the measurements. So we need to have the availability of all the condition measurements for all the assets, because without measurements there can be no management. So in order to manage any asset, we need to know what's going on with this asset. Otherwise, we're just guessing. It's just a guesswork. Then, of course, hand in hand with measurements come all the inspections, because we are still performing regular inspections like walking inspection, track walk inspection, and stuff like that. So all of those inspections, but now we also have the ability to use the modern uh, autonomous inspections based on the machine vision systems, which are increasingly getting used by various railroads. And this is providing a wealth of high quality data for the asset management systems. Of course, we need to use all kinds of planning data. We need to use all the information about the works that have been carried out in the past, as we already discussed before. We need to know, of course, the all the characteristics of the infrastructure assets, which means the asset inventory must be sitting as the bottom layer of any RIAMs. And finally, we have to have the information about the costs of both the assets, components, and the maintenance renewal works. In a bit more detailed overview, we can just break this up further down in terms of inventory data, which means asset register. So we need to have map data that contain track layout, information about curves, transitions, slopes, super elevations, and stuff like that. Then, of course, we have to have the inventory of objects, their location, and location has to be very precise so that it can be correlated with the condition monitoring information. Then object characteristics, including types, installation dates, and so on. Then, of course, we need to include also the operational data, like train speeds, annual loads, axle loads, costs, and line categories, because they're all influencing, in terms of speeds and loads, they're influencing the deterioration of the assets. And in terms of line categories, that also affects the prioritization that we are performing within the asset management system. In terms of condition measurements, I will just mention but a few. Actually, this is a ever-growing and rapidly growing list of systems and measurement types that are being currently used within the RIAMs. It's like track geometry as a mandatory system that practically all railways use nowadays, plus rail geometry, corrugation, wheel rail forces, ride comfort, ultrasonic measurements, rail surface defects, ballast percentage of fines, geotechnical and petrographical analysis of ballast, sleeper cracking and clustering of cracked sleepers or damaged sleepers, various visual inspection data, including, as I just mentioned, machine vision, which is extremely important, new technology that is coming in over the last 10 years. And finally, we need to include work history, including maintenance renewal works, by including their information about type, date, location, and cost. But also we need to include the information about inspections that have been performed and all other interventions. As I mentioned before, the importance of this is that we can correlate those works that have been performed at certain locations and on certain assets with the measured asset condition and the deterioration models for those assets, to see if indeed those works have improved the condition of those assets and remedied their condition. If not, well, the simple conclusion is not to do them again and to seek a better alternative. So at the end of the day, what are truly the benefits of condition-based approach and condition-based asset management concept and asset management system as an embodiment of such a concept? Primarily, it's the reduction and minimization of accidents and derailments. Here we're primarily thinking about derailments. However, there, of course, the extreme. I mean, that is something that certainly should not be happening on any railroad. And asset management systems can indeed contribute to that goal considerably. But very important aspect of the asset management system application lies in taking control of dynamic forces, which as a result brings the extension of service lives of all the assets. Primarily here we're talking track assets, which are being exerted by the dynamic forces. And this extension of asset service lives is exactly what brings the largest cost saving. So further on, the application of asset management system allows us effectively to shift from corrective to preventive and actually predictive maintenance, as we just mentioned before, which means that it allows us to act before defects have already occurred. And this, as a consequence, brings reduction of defects and damages, minimization of traffic disturbances, and speed reductions, and allows us time for proper planning and resource allocation optimization, which again brings the cost down at the end as a result. And finally, the application of an asset management system allows us to perform various what-if analyses. And that is, again, an issue that has been somehow underestimated over the past 10, 20 years. But in my mind, this is extremely important aspect of asset management systems, because these what-if analyses allow us to test different maintenance management policies and strategies in vitro. So we don't need to apply them and then see in reality what's going to come out as a consequence. We can actually, if we have good deterioration models and maintenance and renewal decision rules, we can effectively test and simulate various maintenance management policies and strategies through these what-if analyses, and the result of that can be the optimal strategy for us, for a certain particular railroad, because different railroads operating under different circumstances will actually have somewhat different optimum maintenance policies and strategies. Certainly some, say, the safety thresholds for the certain condition parameters would stay the same. Of course, if the rolling stock is similar and in the layout and track layout is similar. But in terms of maintenance thresholds, they are not that strict as the safety thresholds, because maintenance thresholds are activity thresholds, and they are based on not only on the actual quality of the assets, but also it relates very much to the availability of our resources, to our machinery, our staff, our track possession periods, and so on. So maintenance thresholds are quite far from the safety threshold. So we have quite enough of freedom to vary them within certain windows in terms of thresholds. And by varying them, we can actually establish the optimal values for us that allow us to still keep our assets within the required tolerances, of course, protecting safety of traffic at all times. But on the other hand, it allows us to optimally use our resources the way we have them, because the different railways will have different resources, different number of machinery, different they will have different traffic frequency, and hence they will have different time windows for maintenance or renewal activities to be performed. So every railways, by optimally asset management systems, can actually define their own optimal maintenance management policies and strategies. With this, I can just say that this concludes the first introductory session on asset management systems on our WeThink platform, and we hope that you like this presentation, and we're looking forward to having you again on the continued sessions within the entire series of sessions devoted to this very important asset management issue. With this, thank you very much for your time and attendance. It's been a pleasure, and we hope to see you soon again. Bye.